Liquid steel from basic oxygen steelmaking can contain oxygen, hydrogen, and carbon. To further refine the steel, remove dissolved oxygen, hydrogen, and reduce carbon content via the RH process is achieved by the following steps. The ladle of steel is placed on a transfer car and moved into position below the degasser. The degasser is a refractory-lined vessel connected to a powerful vacuum system. Two internal and externally refractory-lined nozzles or snorkels are attached to the lower part of the vessel. To treat the liquid steel, the degasser vessel is lowered until the two nozzles are immersed in the steel in the ladle. The pressure in the vessel is reduced by pumping system. Steel is encouraged to circulate up one nozzle, the up leg, and down the other, down leg, by the injection of argon into the up leg through a number of small bore pipes. A continuous flow of liquid steel is produced from ladle into the vacuum vessel. Very high rates of liquid steel circulation can be achieved. The vessel is equipped with vacuum lock through which alloys can be added without disrupting the vacuum. Alloy additions are made to enhance the steel's chemical and mechanical performance, as per the customer's specification. During the degassing process, certain grades of steel can benefit from aluminium additions. Aluminium reacts with oxygen exothermically and contributes to maintaining the ladle at temperature suitable for subsequent casting. Aluminium oxide formed adds to the slag, but some is retained in the melt. This can lead to unacceptable levels for tin plate grades of steel. RH Degasser vessel equipped with oxygen injection can further decarburize steel, that is, reduce carbon content within the liquid steel. A further benefit of vacuum degassing is alloy control. Special properties can be obtained by microalloying, with very small but precise quantities of trace elements such as boron, titanium, niobium, vanadium, and even rare earth metals. These metals must be present in solution, but they have a high affinity for oxygen. By adopting vacuum treatments, control of the tiny additions of these elements can be made effectively.